Thank you for presenting me. I'm Leonardo Messi from Polytech University of Marche, Italy, and it's a pleasure for me being here and presenting the results of our last research. So I'm going to present the paper entitled Development of a BIM-based spatial config simulator for detecting dust hazards. So let's start saying that in construction sites, as demonstrated by several past studies, each activity requires a specific workspace to ensure constructability and efficiency. So the space must be considered as a limited resource since the space in the construction site is the one we see in the limit of that and no more. So we can add to this consideration the fact that due to construction site dynamics, space demand changes continuously over time, as demonstrated by the construction workflow model provided by Francis and reported in this slide. So in this domain, in the last year's past studies provided relevant high-tech space management solution, basically based on 4D BIM models. And the contribution provided by this study to the body of knowledge are relevant because they enable us to detect spatial configs in the 3D dimensions, but some limitations still exist. In fact, this approach leave uncovered the possibility to detect interferences between workspaces that are not overlapping, because current researchers detect interferences between static workspaces. An example between an example of the open problem is the one proved by dust spreading in the construction sites, as shown by this animation reported in these slides. So in order to address the topic of dust spreading and dust hazards, we have to make some consideration about this topic. Dust spreading is a very relevant topic in construction sites. In fact, according to statistics, construction sites are one of the measures responsible for creating particulate matter. And although the correlation between concentration of particulate matter and health diseases dates back several decades ago, and dust concentration threshold have been already set by regulation, no study has already addressed the topic of spatial interferences due to particulate matter. So to address this open problem, we need to simulate how the construction site evolve across time, and we need to do that also considering how external factors can affect that. So we need to simulate how it evolves according to weather condition. And this is why we propose a BIM-based spatial config simulator that, first of all, replicates the state-of-the-art in terms of workspace generation and visualization. And then we propose a tool that contributes to the body of knowledge by simulating dust spreading caused by scheduled activities under the effect of wind conditions. So the proposed simulator is regulated by the system architecture reported in these slides. And a few comments about this architecture. We have the BIM model and the work schedule that are provided to define the 4D model and workspaces within the spatial config simulator. To carry out realistic simulation in this environment, the simulator requires mechanical physics and weather forecast data in order to replicate the real expected windy condition for the scheduled days. And dust concentration measured within the virtual environment goes to the reasoner that if dust threshold has not been exceeded, the work schedule will be confirmed and delivered to the execution phase. Otherwise, the expert gets the list of spatial interferences and can apply some mitigation actions, like, for example, the update of the work schedule, the update of the workspaces, and also the prescription of additional PPE for closer activity involved in concurrent activities. So in these big pictures of the system architecture proposed, we focus on the development of the spatial config simulator. So the first step so the first step is mentioning the system applied for this kind of development. We use Unity 3D for several reasons. I'm trying to sum up because it offers a 3D rendering environment with naturally embedded mechanical physics. That is one of the requirements for the spatial config simulator shown in the previous slides, because commercial tools for importing weather forecast data into Unity 3D already exist. And finally, but not for importance, because serious game engines like Unity 3D support the C# programming language to implement very specific function we need. So as a first step in the workflow of development, we need to define the 4D BIM model according to the state of the art. So we import the BIM in FBX format, and then thanks to some C# scripts we developed, we imported the work schedule in CSV format. At this point, we have all the information for the definition of workspaces. Defining workspaces as reported in these slides in light green is important because it enables us to know where dust emitting and receiving activities are located in the construction sites. And so next step consists in simulating dust spreading in the virtual environment. We did this task in two steps. The first one is defining a dust emitter as a particular system. Whose emission rate is given by the equipment involved in activities. Such information are made available along with the work schedule already imported in the previous phase required for the definition of the 4D model. And the second step consists in importing wind speed and wind direction by means of other C# scripts we define. We applied a tool called real-time weather, commercially available, that has shown here reports many forecast data, and we use the wind speed and direction that are, thanks to our scripts, used to fill the fields of the wind zone within Unity 3D. At this point, we can simulate the dust spreading in the construction site according to data provided by the work schedule, and we have to measure the dust concentration, measuring the number of particles colliding against the workspace as proved here. And so we know the volume of the workspace, and we can compute the concentration. So we applied the developed tool in a real use case, that is the construction of a building included in our campus, the venue of the Faculty of Medicine of my university. For better managing the results, we focused on 4 concurrent activities that are reported in these slides. We have the first one, that is the production of formworks for the style wells located in the central areas. That is the dust producing activities. The last 3 are the dust receiving activities that corresponds basically to the installation of the precast pillars in that area, precast facade close to that, and the placing of the industrial flooring at the bottom level. So we carry out the experiment design by determining the number of particles that the dust producing activities, so the construction of formworks are producing in the construction area by considering the equipments involved. We have 3 equipments, 2 circular saw and orbital sander. We consider the inhalable fraction, that is the one most dangerous according to specific domain literature, included between 10 and 100 micron. And we applied a uniform distribution. So the resulting number of particles have been used to simulate the particle system within Unity 3D. And finally, after some sensitivity analysis and tool calibration, we carry out the simulation for the 2 days considered in the work schedule. So for the January the 30th and January the 31st. In the first day that is reported in these slides, weather forecast data provided this one direction that is oblique to workspaces, and the wind speed was not too low. And this demonstrates why the dust concentration between these workspaces is quite low. In the second day, the direction is parallel to workspace, and this is why the concentration is 0, 0, 0 in the 3 workspaces. So jumping to conclusion, we can say that thanks to this study, we have demonstrated how a BIM-based spatial conflict simulator can be applied to detect dust hazards by simulating not only the work schedule, but also weather forecast data that are provided by external tools. And this proves how this kind of information technology management can pave the way for developing future tools in the in line with the digital twin technology for real-time managing dust hazards in construction sites. So thank you very much for your kind attention.
Thank you.